This is the center of a massive galaxy, where a celestial sphere with the weight of billions of suns physically distorts light near it. Under our current mathematical consensus, all of this enormous, measurable mass eventually collapses into a single state, the singularity. The math defines a singularity as a point of infinite density that occupies absolute zero volume. There is a deep logical friction in this definition. As this diagram shows, our equations compress the physical weight of a billion suns until it vanishes into a zero-dimensional dot. The error symbol appears because, at this point, the known laws of physics effectively break. Beyond-Light Rotational Spacetime Theory, or BLRST, proposes a conceptual framework to resolve this contradiction. BLRST views the singularity as an observational boundary. It marks the specific limit where our current mathematical tools and instruments can no longer resolve physical structure. This suggests that black holes contain highly compressed, intensely organized physical structures that we simply lack the means to see. To see how these structures might stay organized under such pressure, we can look at the dynamic stability principle found in standard orbital systems. The Moon remains in a stable orbit because its continuous lateral motion and velocity perfectly resists the Earth's gravitational pull. This balancing act scales up with mass. In systems with multiple stars, the increased gravitational complexity forces the entire structure to develop more intricate rotational behaviors to maintain stability. BLRST maps this progression through the universal rotational compression chain. We start here with a low-density field of particles. As matter accumulates, gravitational pull squeezes the system inward, sharply raising the core's density. To prevent a total collapse, the system must spin exponentially faster as it compresses, converting gravitational energy into intense rotational velocity. At a galactic scale, this creates an ultra-dense, hyper-fast spinning core. The intense glow at the center represents massive kinetic energy holding the system open against gravity. Because this motion continuously pushes back against gravity, stellar evolution culminates in a high-speed rotational engine rather than a collapse into nothingness. These engines operate through layered rotational gradients, similar to the physics of a whirlpool or a massive hurricane. In these systems, rotational speeds accelerate as they move inward. While the outer rings spin slowly, the internal layers reach much higher velocities. This speed differential remains constant even as we move into a dense gravitational well. The core continues to spin significantly faster than the edges. At the very center of this mass, the rotational velocity reaches a threshold that fundamentally alters the surrounding spacetime. Here, the internal speed is so high that light can no longer penetrate or escape the dark core. BLRST proposes that the speed of light represents the maximum threshold for electromagnetic observation, rather than the absolute speed limit for internal spacetime processes. Because these internal layers spin faster than our electromagnetic instruments can track, the structure becomes effectively invisible, appearing to us as a void. In this view, black holes appear dark because their internal rotation is fierce enough to outrun the light we use to observe them. This principle extends far beyond the black hole. At the macro scale, we see these same rotational dynamics organizing the sweeping arms of entire galaxies. Within this framework, a singularity is a mathematical signpost indicating a region of unresolved physical complexity. The observed effects of gravity, like the bending of light and the slowing of time, emerge from these underlying rotational gradients. This creates a single evolutionary chain. The same rotational physics that keeps a moon in orbit eventually drives the organization of the most massive galaxies in the universe. Matter entering a black hole is physically reorganized by intense rotational compression, being recycled into the system's dense internal structure. This positions rotation as a central stabilizing force, providing the kinetic energy necessary to organize matter into the coherent, large-scale structures we see throughout the cosmos.